Okay, well, thanks everyone for coming. It's good to see such a large crowd. So I'm Ryan, I'm the speaker, and I'm principal data consultant at Thoughtworks. And mostly my job revolves around helping customers get value from their data. But in this session, we're going to focus more on the technology side of things rather than the business value. But we're going to see that those things are deeply linked, and that's going to be kind of the theme of the presentation. So I think everyone here knows that data mesh is pretty big. I personally, I like to kind of get my head around it by thinking of it as like microservices for data. And in this presentation, we're going to see what that means, or how that's a helpful comparison. And we're also going to talk about why data mesh is catching on, what the real reasons are behind it. And that will help us get a better understanding of how all the tech that's available on the market fits in, and we'll get a feel for what a data mesh can look like in practice. And I'm also going to talk about what some of the challenges are that are involved in actually building out a data mesh in practice. So this is quite a lot to cover in quite a short time. So we may not get around to questions. Sorry about that if we don't. But I will be at the booth just outside, booth 237, which is like just there. So you can grab me for questions there if I don't have time for it. So data mesh is pretty big. In fact, this is the data mesh track at Big Data London, so it's really big. We just heard from Shamak. Me, personally, as a consultant, I'm seeing a lot of organizations that are looking to implement data mesh, but I'm also seeing that there's a lot of confusion about what the most important parts are and how to make it work in practice. So let's start by understanding the essence of data mesh and what's involved in applying the ideas. First, let's talk about what problems data mesh solves. We can understand data mesh as a response to certain problems in current data architectures. Popular data architectures tend to be centralized and monolithic, with one team looking after lots of different types of data, and often in just one place, like a lake or warehouse.
Morning, everyone. My name is James Gardner. I'm the Director of Data.
The pain points we see with these architectures are generally connected with the central team becoming a bottleneck, or the central tech becoming a constraint. The team then can't keep up with the details of all the data, and they just don't have enough time to properly collaborate with all the different operational teams who maintain the systems where the data really comes from. So what you get is bad data and broken pipelines. The central lake or warehouse becomes a place where the data goes to die. Data mesh diagnoses the problem with monolithic data architectures as having aligned data architecture around technology and not business needs. So instead of having a warehouse team or a BigQuery team, we see teams in data mesh aligned to business domains. This enables teams to really know and own the data and make decisions with more autonomy and ultimately deliver more value. The big problem with monolithic architectures is they don't scale well at the people level. Centralization either creates bottlenecks or it creates too much distance from the data to be able to really get full value from it. Data mesh offers a way to scale both the technical data ecosystem and the people that create that ecosystem. So maybe these themes are now sounding familiar to you if you remember the microservices comparison was going to come in. Well, here it is. So we've got talking about centralized monolithic technology and tech-aligned teams, and we're moving them to a decentralized domain-aligned arrangement with empowerment. So those are the key themes for microservices, right? Well, let's just make these parallels super clear. We're talking about moving from a centralized monolithic architecture like data warehouse or data lake to a distributed ecosystem. The distributed ecosystem can be polyglot, meaning that teams can choose whatever technology fits their use case. Think of how in a microservices architecture, teams are able to choose the most suitable language and library. Likewise, data mesh lets teams choose to use the best type of data storage for their use case, rather than having to use the lake. And domain alignment means that you don't have a data warehouse team or like with microservices, you don't have like a UI team or a backend team. Instead, teams are devoted to specific business areas like customer onboarding or stock and order or marketing. So perhaps the most important thing that microservices and data mesh have in common is that they're both architectural styles with wide-ranging implications for the organization. Zhamak Dehghani, who we've just heard from, describes it as a socio-technical approach. It's not just about technology or systems design. It's also about organizational structures, governance, and culture. Actually, it's often the softer sides of data mesh that prove more difficult for organizations to get to grips with. Likewise with microservices. Now, microservices are a useful comparison for data mesh, but there are also differences. All architectural decisions involve trade-offs. Here's a great way to think of the core trade-offs of microservices, courtesy of my Thoughtworks colleague, Chris Ford. If we break things into small pieces, we can change them independently, so long as we don't mind the added integration complexity. The "so long as we don't mind" bit is important. If you break things up, then there's a bit more cost to making the pieces work together. Now, the trade-offs involved with data mesh are similar, but a little bit different. Here we can put the data mesh key trade-off as: if we devolve responsibility for data to the people who produce it, we can rapidly incorporate new data sources and use cases, so long as we don't mind distributing skills and investing in self-service infrastructure. Again, the "so long as we don't mind" bit is important. We're breaking things up again, so there's going to be a cost to putting them back together and make them work together, and part of that cost is the self-service infrastructure. So let's get into more detail now about what it means to implement a data mesh. Let's start with data products. A data product is not simply a dashboard or a report or a data set, though these things can be parts of data products. The data product isn't just a specific analytical output, but also everything that is necessary to make that output happen. It's the data storage and processing code, the transformation logic, the code that handles reading in the data, the documentation that people use to find out what the data product offers, and also any metadata that the data product exposes so that it can be discovered on the mesh. A data product should be focused on a specific business function. It should have a core use case, and the data product should be implemented in a way that is consistent with the rest of the mesh. Now, here's another view of what a data product is and what it contains that reveals how much variety there can be to data products. There are common elements shown here: the input layer, the output layer, the processing layer, and governance. Actually, you can't see the governance, I'll just bring it up. But there can be a lot of variety about each layer. The inputs to the input layer can be an operational system, or it can be another data product, or it could even be an external data source like a public data set. It could be that the data product calls an API to get its data, or it might read from a stream or read a file as a batch job. The processing layer can have a lot of variety too. The computation might be in Spark or Airflow or in a SQL database, or a different kind of database. Or there might even be some machine learning thrown in there. The output layer can have a similar variety to the input layer. It might be streaming or batch or an API or multiple outputs. The governance features in a data product are easy to overlook. The data product might expose metadata for discovery and for showing its listing in a catalog of data products. It might also expose quality and performance checks, as well as logs to indicate the data product's health. Now, here's a view showing the arrangement of data products, this one from the original data mesh article by Zhamak Dehghani on martinfowler.com. This shows how data products can be divided up and how they can relate to each other. Here we see 3 different domains for a music streaming company. There's the artist domain, podcasts, and users. In the top left, we have operational systems to onboard and pay artists. These 2 systems together feed the artist data product, which can offer insights on which artists have been earning the most in different time periods. At the bottom, we have the users domain with a single operational system for user registration. The user profile data product is fed by that one operational system. It has 2 output ports, one for monthly summaries of user profiles and one for feeding user profile updates, say as a live stream. So we see here that data output ports can be live feeds at a record level, or they can be aggregated data supplied on a schedule. The stream of user profile updates is consumed by a data product in the podcast domain up in the top right. The data product up here in the top right takes input from two operational systems, and one in the podcast domain and the other one in the user's domain. So we see here that a data product can belong to a certain domain, but still take data from a different domain. We're now going to move towards what capabilities you need for a mesh and for the data products on the mesh. But to get there, we first need to recap the 4 principles of data mesh, as the capabilities will flow from the principles. The first principle we'll look at is domain ownership. We've talked about this already and seen it in the previous example for the music streaming company. This one is mostly about how you organize your teams and identify and carve up your data products. It's a super important principle, but actually it's the other 3 principles that have more implications for the capabilities at the technology level when it comes to building the data products at that level. So we're going to move on to the next principle. Now, data as a product works hand in hand with the domain ownership principle. Teams need to be given autonomy and allowed to get close enough to the data to really own it. This enables the team to handle the data product as a true product and not just as a data filed away and forgotten. The autonomy side of this means you need a variety of tech to be available for implementing data products. You can't just impose the same database type on every data product, for example. And treating data products as products means teams are empowered to delight their consumers. So data products will have capabilities to expose data in various ways and report their quality and expose high quality documentation that explains the meaning and origin of the data as well as its format. Now, the self-service platform principle is about empowering data product teams and also enabling some standardization. This provides a foundation for the mesh implementation, like a soil that can help all the data products to grow. The platform should provide ways to bootstrap new data products. This could mean templates or starter kits. Or for an advanced mesh, there might be a dev portal with a wizard that provisions resources using templating. We'll get a bit more into that in a bit. So we've mentioned in the other principles that data products should be easy to find and that there should be standards and policies holding them together. The federated governance principle makes this explicit. Part of this principle is also about culture and people. Federated governance is best coordinated using a governance board with representatives from a range of data products and other interests. So it's quite different from the centralized and top-down model of governance that many of us are familiar with. Federated governance also has implications for the capabilities that are in play in data products and in the mesh. You want all data products to be findable in the same way and from the same search facility. You want them to use a common format for reporting their quality and monitoring and any audit trails. So this slide brings together the capabilities that we've just talked about and breaks them down by principle. At the platform level, there's provisioning of resources using templates or wizards in a dev portal. For good governance, we want a catalog that can make all the data products visible to potential consumers. We also want standards and policies and monitoring tools. For data product teams to have autonomy, we want a variety of data storage tools and technologies and formats for input and output ports. There may also sometimes be specific integrations that apply to data product interactions, or which cut across multiple data products, such as a federated query facility or data virtualization. Now let's think about how these capabilities fit into the user experience of the mesh. There are different user experiences for different personas interacting with and working on the mesh. It's helpful to think of the mesh as having different planes aimed at different user personas. For data product developers, there's the data product experience plane. This is a kind of platform where data product developers can find other data products to connect to and tools for bootstrapping new data products. This platform has to be built out of some underlying tools, and somebody has to build it. The somebody that builds it is the data platform developer. they build the data product experience plane using tools from the platform infrastructure utility plane. Now, if you don't have a data product experience plane, or it doesn't have everything that data product developers need, then they can go straight to the platform infrastructure utility plane. Let's get a bit clearer on what a data product experience plane can be like. Imagine you're a developer building a data product. The platform would give you a way to say that you want one graph database, for example, for storage, a Spark instance for ETL, and also permissions to load specific files from S3 as an input from another data product. Then the platform would bootstrap the resources for you and apply further templating to give you a skeleton of endpoints for discovery of the data product and exposing metadata. Or maybe you choose a different set of options, like a MongoDB database instance instead of a graph database, or different kinds of output ports. If we're lucky data product developers, then maybe we'll get a UI with a wizard to help us out with this. Now, there are developer experience portals for microservices, which are a lot like this. Spotify has one, and they've open sourced the foundation of it as Backstage. Actually, Backstage isn't so much a portal as more like a starting point for shaping your own in-house portal. Developer portals like the ones that you can build with Backstage enable developers to use templates to bootstrap new microservices and pick from a curated set of technologies. Unfortunately, there's no off-the-shelf equivalent available for data mesh right now. So to build a data mesh experience plane with a smooth UI experience like this, then you have to build a lot of that yourself. So we've talked about the two planes aimed at data product developers and data platform developers. There's one more plane left. The top level plane is an experience plane for consumers of the mesh, the data analysts and data scientists and business analysts. This is a very different audience with a different set of needs. They want to find data products, understand the data, understand the format of the data, request permission on data products, and ultimately use the data products to answer questions and solve business problems. So you might be wondering whether you need all of these capabilities, and the answer is basically, it depends. Meeting all of these capabilities can be a lot of work, and the truth is that not every mesh needs every capability. There's no definitive list of you're not a mesh if you don't have this. But of course, if you don't have any of these capabilities, then you're really probably just not a mesh. It's obviously a lot of work to build up all these capabilities, and you have to make decisions and trade-offs. There are off-the-shelf tools and platforms that can ease some of the burden, but it's not exactly easy to make choices about those. Part of the challenge of making these choices of technologies is that there's just a lot of them out there, and it takes a lot of time and expertise to understand what they all do and how they relate to each other. Now, the logos in this slide are just a selection of platforms and tools. If you look at the quite famous MAD landscape that's published by Matt Turk, well, there's just way, way more on there, and you can't fit it on the slide. I've attempted to put some order on this chaos and have set up some tables in the GitHub repo. The link at the bottom of this slide is a link to that GitHub repo. The table looks at features of commercial data platforms, and the feature categories correspond roughly to the categories that you can also find in standalone tools. And the repository does have details of standalone tools as well, but I can't fit that on the slide. In fact, there's more platforms I can't fit on the slide either. In fact, there's a second slide just because I can't fit all the categories on either. But what we're going to do is we're going to go through some of the key categories and understand how tools in these categories can be useful for data mesh implementations. So the content from this slide is from the GitHub repo, as I was saying, and on the left is the categories, and so there's some more categories there, and at the top there's a listing of different data platforms that are available on the market. But even my simplified model is too big for a slide. Anyway, we're not going to get too far into the details. I think what we can achieve in this session is to understand the categories a bit better. So let's just start with a quick look at the data catalog or data discovery category. Basically, a data catalog is an index of what data the organization holds, where all of it is, and the metadata about the data. This makes the data findable and usable. The catalog may have discovery or crawler service for finding data, but typically data can also be explicitly registered. Having data products register themselves is probably more in keeping with a mesh philosophy than using crawlers, as this way, with self-registration, the ownership of the data that goes into the catalog is the ownership falls on the data product to provide that. Once data is registered, then users can search for it. If a user of the catalog finds data they want to access, then they need to go through some permission request flow. Setting permissions for data sets and even tracking the lineage of data sets can be a data catalog feature. Or sometimes platforms have permissions and lineage as a distinct concern, separate from the catalog. Either way, these are capabilities you're going to be looking for, as allowing users to discover and request access to data is a key feature of the mesh experience plane and a key capability of a mesh under the federated governance principle. A data platform naturally needs to provide data storage and a way to query data in the storage. Most platforms provide a lake or warehouse option, and some provide both. There are also hybrid lake and warehouse types of storage available. Pretty much all the platforms that I've surveyed provide ways to store, transform, and query both structured and unstructured data. Warehouse and lake storage are both likely to be needed by data products, and polyglot storage is a key capability flowing from the data as a product principle. It's worth noting that most platforms provide options for this, but not necessarily in a data mesh way. A data mesh way would let you define particular transformations as belonging to a particular data product. The polyglot storage aspect of data mesh also means that document, graph, and time series databases might find their way into a data mesh, even though these are less common in analytical data stacks. Typically, data platforms have some sort of NoSQL option, but how many options and how mature they are can vary quite a lot. The cloud providers have these options, and that's mostly because the cloud providers are catering also to operational teams, where these types of databases are more common there. Data platforms that specialize in analytics are less likely to have these kinds of options. So this can be an area where you might have to pick a platform to support your mesh, but you might find that that platform's not quite enough, and you also have to bring in custom tools for particular cases. A platform naturally needs to provide data storage and a way to query data in the storage. Most platforms provide a lake or warehouse option, and some provide both. There are also hybrid lake and warehouse types of storage. Wait a sec, I'm talking about the wrong slide, aren't I? Yeah. Okay, so yeah, there's also streaming architectures. And as we've seen that streaming is a key aspect of the output ports that will be needed, and it's commonly used in data mesh architectures. This is because it allows for an event-driven architecture where you can then queue up messages and basically build the data products in a chained way and let them handle the flow as they wish. There's certainly products on the market for this, but you'll find that there's quite a lot of difference between the pipelining tools that are available. Now, reporting and BI tends to get missed, I find, quite a lot in data mesh, but I feel like this is quite important. I feel like the problem is that data architects tend to be kind of back-end centric, but reporting and dashboards and are also key aspects of getting value from data products. And for this, the data reporting and BI tools are another key element that we should be looking at in our platforms and our selections of technologies. So that's some of the most relevant categories of data platform features and tools for data mesh implementations. There are more categories I would have loved to discuss and love to go through in more detail, but I think we've said enough to see that data platforms are useful. But we have to be cautious because what data platforms provide right now is not the same as the data mesh platform plane that will empower data product developers. There's nothing like the wizard or templates to build a data product that we talked about as part of a data platform experience, though some platforms are starting to provide some templates. The fundamental gap is that these platforms have been designed around an idea of providing specific services and not data products. So to build a data mesh platform on top of a commercial data platform currently takes work and can be awkward in places. There is an alternative to starting from a commercial data platform. You can start simply by selecting a range of individual tools, maybe a mix of open source and specialist commercial tools. These can be curated and assembled and a platform layer built on top of them. Naturally, it's a lot of work to get the platform experience that delights developers. The integration can be tricky, and the tools probably weren't originally designed to work together in a mesh. Much like the commercial services in data platforms weren't originally designed to be used in a mesh. Let's get a taste of what some of the integration work for a data mesh platform can involve. I work for consulting firm Thoughtworks, and we partnered with Saxo Bank to build self-service data infrastructure. Data Hub was the chosen data catalog, but at the time there were limitations on being able to show quality metrics about data sets in Data Hub. So Thoughtworks and Saxo contributed an open source plugin to that integrated a data quality tool, namely Great Expectations, to make it work with Data Hub. This has then been productized under acryldata.io. So this gives a flavor of the tool's ecosystem and where it's at right now, in a sense. On the one hand, the plugin has now been developed and it's being productized. But on the other hand, it wasn't available when we first wanted it, and that wasn't really all that long ago either. And this also gives an illustration of how an integration that when you start on your mesh journey, you might think it's not that important. But when you think about it, you can see how valuable it is to have these quality scores and to inspire the trust in the data set. So we've seen there can be a lot of work involved in setting up a fully featured platform plane to support data product developers. In some situations, putting up that upfront work can be overkill. Maybe you won't have all that many data products. Maybe they'll all be pretty similar. It can also be challenging to justify a lot of investment upfront when you want to be getting value early from the data products and getting something live. In these cases, it can be okay to be pragmatic and provide a lesser experience to developers and users. I'd argue there are situations where it's okay to have a wiki instead of a data catalog. It's not as smooth as a data catalog. It puts more burden on teams to ensure they document things in a consistent way, but it's usable, especially when there's only a few data products. Let's remember that data mesh promise. If we devolve responsibility for data to the people who produce it, we can rapidly incorporate new data sources and use cases, so long as we don't mind distributing skills and investing in self-service infrastructure. So that self-service infrastructure, that's the big trade-off. There's a cost involved in building that, but you can stagger that cost and tailor it to your particular use case and the particular use cases of your mesh. Before deciding to invest lots in self-service infrastructure, it makes sense to assess where you're going to get value from your mesh initiative. At Thoughtworks, we recommend undertaking an exercise to map out the key areas where the business value could be unlocked, and identifying the highest value data products. Then you can focus your initial efforts to ensure that your initiative can get big wins early on. In this presentation, we've mostly focused on the technical sides of data mesh, the platform capabilities and the tech available to implement them. But it's important not to let tech questions become a distraction from the biggest questions for your mesh implementation, which don't actually tend to be on the tech side. Remember the data lake and warehouse pain points we looked at the beginning about a central data team becoming a bottleneck. That's an organizational pain point, and data mesh requires organizational change. To achieve that, teams will meet resistance, and they'll need to overcome that resistance, and at points they're probably going to challenge and question where things are meant to be going. You want to be as clear as possible about why you're doing data mesh, what pain points it's going to solve for you, and which data products you'll get most value from. So, data mesh addresses scaling analytics at a people level. It involves a cultural leap to the 4 principles, and implementations have to choose how far they're going to go with each principle. Self-service infrastructure especially can be a big investment. And there is tech available out there to help, but it won't get you all the way without effort. So, thanks for listening. As promised, I will be at slide at 237. Oh yeah, so I can take questions at the booth, 237, just there.